Today I'm going to be giving a video demonstration of my CSC 3002 final year project. The title of my project is Code Level and Requirement Level Coverage Assessment of Model-Based Testing. Before we get into any of the background, I would like to point out at this point that I will keep this video to a high level overview, and the reason for this is so that we can meet our time constraints. I will keep any of the complexities of the implementation of the solution itself to the report. So without further ado, let's talk about model-based testing first and foremost. Model-based testing is a software testing design approach in which we can develop test cases or sets of test cases in the form of an easy to read, easy to understand graph of sorts, where each vertex in the graph represents a state and each edge in the graph represents a action that we would take in order to transition between said states. So there exists an inherent issue with model-based testing at the moment where none of the modern implementations offer a means for a person to be able to collect coverage metrics for them to be able to assess. And the project that I've been working on aims to solve that issue. We were able to do this by collecting our code level and requirement level assessment metrics during the execution of our model-based testing test suite against a given SUT, where we were using GraphWalker as the tool of choice for implementing our model-based testing suite, and our chosen system under test, or SUT, was the well-known Java Pack Clinic sample application. I would like to point out at this time that we had the goal in mind to be able to make this a basis for other people to be able to achieve the same thing with their own project, their own given application on GraphWalker Test Suite, and they would be able to achieve this by simply altering the pathways to the files that would need to be generated after taking a couple of development steps in attaching this tool to their system. So assuming the user has cloned it down from the main repository, we will first navigate over to the folder, and once in the folder, as you can see here, we have a run.sh executable shell script that will automate the process that we are interested in. So if we go ahead and kick this script off, firstly what this script will do is it will stand the SUT up locally with the Jacoco Java agent attached as an argument to the Java virtual machine. This can be achieved through editing your profile file in your Linux distribution, or it can be done through the JVM arguments offered in many popular Java IDEs such as IntelliJ IDEA or Eclipse. Once this is achieved, it will then execute our GraphWalker test suite against our given SUT, and once that has been achieved, it will terminate the SUT and it will collect all of the metrics after the tests have been finished. It will then boot the display system for the user to be able to use. So as you can see on screen, our GraphWalker test suite has now just kicked off against our SUT, and it will navigate around our SUT and perform a number of behavioral tests in order for us to be able to collect the given metrics. So I will let this test suite finish, and then we will come back and discuss what occurs then afterwards. So as you can see, the GraphWalker test suite has now finished. Our script will now continue. It will generate the Jacoco server-side coverage report based on the instrument class files after the termination of our SUT, and now it will begin to stand up our display system locally through cleaning and building it. Once our application has been started, which it just has, You can acknowledge this just by seeing this screen, Start Application. We can now navigate over to our locally stood up system, and this will be by default on port 80. You can navigate to the coverage or the requirement web pages. In this case, I have navigated to the coverage web page. On this web page, we can generate our client side and our server side code level coverage metrics. As you can see here, client side in our recent run was 20%, dictated by this speedometer display and also by the metric posted underneath, which will be dynamically generated upon clicking the button. And the same for server side, 46% was covered within the last run of this test. If you head up to our navigation bar on the top left is our option to head over to our requirements page. If you wanted to go back to the coverage page from this point, you would click the coverage tool in the middle, or the coverage text in the middle of the navigation bar. So here in requirement coverage, you can see that the speedometer display is also here along with the button to generate it, and you can see that 100% of our requirements were covered in the most recent GraphWalker one, the one that we have just finished. And I would like to point out at this point that the GraphWalker test suite was executed with random edge coverage, and therefore it will cover every state and edge before the test suite allows itself to finish, and this is why we have 100% coverage of our requirements, because each of the requirements are attached to a given edge or vertice within the graph. This concludes the execution of the system itself. Given the conclusion of the execution of our system, I would like to take this time to answer two questions that have been posed to me in the creation of this video, and that is firstly how I would have developed and improved upon the project, and secondly what was the technically hardest part for me during the project. So firstly, I would like to say that if I had more time to develop and improve the project, I would have first have liked the project to be more dynamically configurable, in the sense that I would have preferred ideally if this user didn't have to do anything to be able to make use of the tool that I have developed, therefore making it more plug and play. I would have also preferred if the user did not have to have Linux to be able to run this project, and I probably would have achieved this by Dockerizing the entire project so that it would run on multiple environments. Additionally, I would have liked to provide more in-depth analysis rather than just an integer-based value for the code and requirement level coverage percentage, and this probably ideally would have been achieved in a way that this information would have been made easily accessible to the user from our front-end system. Lastly, I would have liked to made the client-side functionality better, in the sense that I would have liked it if it didn't happen at all at one time during teardown, but rather would have happened before and after every element to get a more verifiable metric. Although saying that, it did meet our requirement of ensuring that it was happening during test execution. In terms of what I found to be the hardest part for this project was just honestly how under the hood everything was. Prior to doing this project, my experience was in heavy, bulky, like overhead, full stack development projects, in the sense of like C# and Java web pages with like back end systems and whatnot. And because of that, I ran into a lot of like uncommon software engineering issues around shell scripting, kill signals, how to run detached processes, and how to connect things to your JVM arguments, like stuff like that, where I would have had that handled for me in the past at a higher level. Being forced to be able to interact with that level of programming was very difficult, but also very beneficial because it learned me many things. So saying that, I would like to take the time to thank you for watching my video, and I hope you have enjoyed.